right, class, welcome to our first lesson in the class. Okay. So I'm going to give you first an overview of my PowerPoint as well, but this is uh, the objective of this lesson. So let me start the presentation. Okay. All right, and the in the objective, I linked the two chapters that I asked you guys to read. Okay, so I'm basically I prepare my lesson based on those references. Okay, so I usually call these readings the reading list. Okay, and you guys actually read it doing um, reading quiz, reading quiz in the module overview module, and you guys probably read it again in doing the reading list question discussion. Okay, so if you have questions, you can ask it there, and I'll reply, or your classmate can reply. So it's kind of having a social thing. From if you don't know something, someone can reply, including your instructor. Okay. So anyway, so in this lesson, so let's start our first lesson. So we are going to cover these topics in today's lesson. So let's start. And as I go on, I will explain some few things, important things in my PowerPoint, and how you can use them. Okay. All right. So the first topic is algorithms. Okay. So algorithm is a recipe. Okay. So it's a recipe that that you can basically use it to like solve a problem, right? So it's written in English. Okay. So basically, it's a list of instructions, a recipe to solve a particular problem. Okay, it's really important that you understand it is for a particular problem. So that means the problem is well known. All right. All right. So throughout computer science, it's all about developing algorithms. Okay. And it could be something simple, could be something profound. Like, for example, Google, right? So Google still relies on that their search page. In fact, they are still the number one revenue generator is that Google search page, which they came up as a research back in 90s as a research at Stanford, right? So page rank algorithm, right? All right. So and you can see that it's something simple became too big, like very big, powerful, and well innovative, and you can name it. Google is it's a big company, right? So making billions, right? But still the idea is simple. That simple algorithm still they are number one revenue generator. Okay. All right. So algorithm present the general solution. It's coming in as like we present it as in English. Usually the language is English because in computer science, the language of the code and script they are English, right? So in English, we sort of present the recipe to solve a problem. That's the algorithm. Okay. We write it, like I said earlier, we write it using natural languages like English. Okay. So we write a program to translate that recipe in English into a language that the computer understands, which is usually in binary format, zeros and ones. Okay. All right. So let's write an algorithm. Okay. So at this point, you can stop watching and then get a piece of paper and then write your own algorithm to um, present a recipe on how to make a peanut butter and jelly sandwich, right? So one of America's best sandwich. Okay, so so let's write that algorithm. Okay, so first step, well, we need to collect ingredient, right? So that could be bread, peanut butter, and jelly. All right, and there may be some other some other ingredients based on preference, right? But usually these are the three. So we collect ingredients. If you basically if you want to compare this one to one with something in computing, we collect the inputs. Okay. All right. So and then we the next step basically take one slice and spread peanut butter. It could be spread jelly as well. It doesn't matter. Okay. Take one slice and spread peanut butter. If someone prefer okay before toasting, before spreading anything, you can put it as number two as well. Toasting your bread. Okay. Next step, take the other slice and spread jelly. Right. Well, final step, right? Put them together and serve, and then that's it. And then it's really simple algorithm. But when we present this to someone who don't know, have no idea about how to make a peanut butter and jelly sandwich, well, now that person can easily follow these instructions. That's the whole idea. Okay. So so that's the idea of writing algorithms. Okay. All right. All right. So then let's talk about what a computer program is. So why do we need a program? Right. There are many reasons. But basically, computer don't speak the language we speak. Right. Computer only understand digital things like digital instructions, which is zeros and ones basically, right? So it simply doesn't understand English, by the way. Well, we may seems like it understand English, right? But it's true other programming languages because there are translators inside. But if you take the CPU, it doesn't understand anything other than zeros and one. Okay, all right. So when it since it only understands zeros and ones, giving these instructions in zeros and ones and could be tedious one. Imagine having uh, um, giving your computer instruction in zeros and ones on, like saving your Word document, word processing document, right? So we'll be submitting like millions, if not trillions, zeros and ones, and that's tedious. Okay. And in fact, we started off like that back in 1930s. The first computer like ENIAC, those stuff, that's huge computers. We fed, we call it punch cards, right? This paper card punch, like zeros and ones are punched into paper cards, and we feed those cards into those big, huge computers, right? So when we learn the lesson from it, right? Okay. All right. So right. So when we solve problem in English, then we basically we need a translator now to the computer. Okay. So that means basically we need a translator. All right. So that we can actually program in English. So if we have a translator ready so that it can translate our English to machine code, then we are better off writing zeros and one, but we can now write in English, like syntax written in English. Okay. Right. So we use programming languages to translate, to do that translate process. Okay. And then Python is one such powerful translator. Okay. So, well, there are programming languages, then there are high-level programming languages and low-level programming languages. There are two types of low-level programming languages. Okay. So basically, one is the most fundamental one, the basic one, which is the machine language in binary format, zeros and one. So in fact, the computer can only run code in this format. We call it machine language. So it's still a language because computer CPU works with it. So it's a low-level language because it's more close to the metal inside the computer, which is the CPU and the motherboard and then chips, right? Okay. So the next one is basically it's a little bit above machine language. We call it assembly language. They actually simple command refers to specific instructions that the CPU can take. Okay. So those are very simple commands. So this still it's low level. Okay. So that's why we are still not writing programs unless it's absolutely necessary. We don't write programs in assembly languages these days because they are still primitive, and that makes the programming tedious. Okay. All right. So the advantage. So there are advantages of assembly language, and then some. There are fewer experts in doing this. It's not a lucrative job market, but there are programmers who program chips. Um, Basically, like maybe chip manufacturers employ a lot of them, and these assembly languages or low-level languages, they run fast because they run directly on a specific CPU that the program language is designed to. Okay, so they require, if it is machine language, that doesn't require translation. If it is assembly language, it's require minimal translation. Okay, so there are a lot of disadvantages, right? So it's those languages, low-level languages, can only run the CPU that the language is designed for. Okay, so that means there are a lot of dependencies. Okay, and it's hard to read. Okay, and it's too long. And if it is machine language, only zeros and ones, right? It's really hard to distinct things. And even if it is assembly language, fewer very abstract uh, words would be there. So hard to read, too long as well. And writing takes a lot of time. Okay. So what the high level language does, basically it takes out this, mitigate these difficulties in low level languages. Okay. So the advantages are they are written in English. So everyone can easily read. Short. Okay. So there's less time to code. Okay. So it takes less time to code. So the programs are short. Okay. So less error prone. Okay. So because they are in English, you can easily recognize a mistake and fix it. Okay. They are portable. So that means they don't depend on the machine. So there are ways in which we can make the machine dependency out of the programming language. Not all high-level programming languages, but Python, Java, they call them like machine independent. Okay. All right. And then The other thing is, even with machine dependence, once you compiled a high level language, then you can actually uh, run it again and again on the same machine or in similar machines. Okay. All right. So so then basically these language need a translator to translate this high level code into low level code. Okay. And then basically what we do these days is that we make that translator is really very versatile, so that translator itself lift the majority of weight in converting that high level code into low level machine code, because the program we run these days are really complex. So having, if we are to write them in zeros and one, it would be nearly impossible. So if we design our translator in such a way that we automate the whole process according to a syntax, we call it grammar, and then uh, our task would be easy. So we write a less amount of code, compiler or the translator or the interpreter lift the heavy weight. Okay. All right. So so then basically these translators are called compilers and interpreters. Okay. So disadvantage, well, this translation process has a price. It takes some energy and time to run. Okay, so that's slow down the process, because we are not directly running something on the CPU. There's an intermediate, so that process takes some time. But that's so that we say that there's a time overhead to this translation, but it's a small price that outweighed by those advantages. Okay. All right. So here are the translators. Interpreters, they translate source code into machine code, one instruction at a time, one line at a time. Okay. And then they translate it and then runs it. Okay. So take the one line at a time and translate it into machine code and then runs that code. Okay. That's interpreters. So this is the sort of picture of an interpreter's flow. Okay. So we have code lines, then we feed it into interpreter, and this create executable or machine code lines, and then they gets executed and we get the output. Okay. So this is like a sort of like ongoing process, one line at a time. It runs and we get the output. We get to see the output. Okay. So compilers, excuse me, basically translate entire source code into machine code, then runs entire machine code. Okay. So then once you compile, then we can execute that compiled code many times. So here is the diagram for compiling. Okay, compilers. So we have code file. So this is the text format. Okay, source code. We have the compiler, and basically it creates the executable machine code, basically file. We call it sometimes object code or executable code, and we get the output. Okay. All right. So so some languages like Python use these both translations. Okay. So basically this is what we have with like language like Python or Java. So code, we have the compiler, and first Python compiler create the object or bytecode. We call it object or bytecode, and then the interpreter takes that and then takes that code and line at a time and then generate the output. Runs one line at a time. Okay. All right. So for Python specifically, this is what we have. Okay, so code, we have the code, we have the compiler, and compiler generated bytecode, and then Python virtual machine, Python interpreter, Python virtual machine take that code and then runs one line at a time, Okay. All right. So there are two ways to run Python code. Okay. One is shell mode. Okay. So run simple code at this Python prompt. This three arrows together, it's called the Python prompt or Python terminal as well. Okay. And the other one is program mode. Basically, again at the prompt, you take the entire file, okay, source code file, and then runs it. Okay. So we can use either one, but usually if we use a integrated development environment, so IDE, you will not see any of these. Okay. But I'm going to show you now how to run the Python shell. Okay. So I'm at my terminal. Okay. If it is Windows, this is it will be command line. If it's a Mac, it will be something similar to this terminal. So I'm running Linux. So this is my Linux terminal. So inside my terminal, I type Python 3.9. So if I print Python 3, I have Python 2.7. So I'm going to run Python 3.9 by directly specifying the version. So I have installed Python 3.9.5. Okay. All right. So now this is that prompt that we were talking about. Okay. All right. So simply we can type things here, right? We can add, we can use it as a calculator, right? And we can use it to print something like hi, right? Right. So this is what we call shell mode. Okay. So right, shell mode, and the programming mode basically. Let me just go to a place where we can. Okay, so we have this um, hello world program. Find it out. I'm going to find a different file. Okay, so maybe what I'm going to do is I'm going to create a file. Let's just do that. Okay, so I'm going to go to my text editor. Okay, so I'm going to do is basically I'm going to print. I'm going to create a file, code file. Okay, so hi. Okay, I'm going to save this as .py file. Okay, so I'm going to do it over here. Okay, this is where our class materials are. So I'm gonna let's say hi.py. Okay, so hit enter. So I saved it. Okay, so save, and what I'm going to do is I'm going to go to that location. Okay, so I'm going to go to that location right here. It should be right here. Okay, all right, this is my file. So I'm going to get this path copied. Okay, and you don't need to do all this. Okay, so just I'm showing you guys. All right, so I'm going to change the directory cd. So these are, oh sorry, I'm gonna go away from that and cd. So this I'm changing the directory in the command line. Okay, if you don't know this, don't worry about it. Okay, we are not going to rely on this system too much. Okay, all right, and then oh okay, I didn't copy that, so let's see. All right, so let me just go there again. All right, copy. All right. So now I'm there. Now I'm going to run Python over here. Okay, so Python 3.9. So I'm running now Python in this location. So I can now simply run py. Okay, let's see. Okay, so the shell mode, programming mode. Sorry, I need to go back to where I was. Then I type Python 3.9 and then the program. Okay, so hi.py. Okay, all right. So this is my line of code. Okay, so this is where I'm running up. Okay, the program that I saved. Okay, all right. So it printed hi. Okay, all right. So this is the programming mode. Okay, but anyway, we're gonna use an IDE. So don't worry about if you are having difficulty running in this mode. This is really crude. It's only good for simple stuff. Writing and running a complicated program, we need a more sophisticated environment, and you're going to soon see them as well. So let's go back to our lesson. All right. All right. So let's see. All right. So let's go to our presentation. Okay. So we were here. All right. So we were here. Okay. So we visited two ways of running Python. Okay. All right. So let's learn about some programming concept. Okay, so and what a program is, and then we're going to move on to our next level. Okay, so a program is a sequence of instructions that specifies how to perform a computation. Okay, so it's a sequence of instructions. So instructions, sometimes call them statements, that specifies how to perform a computation. It could be like, solving a problem. Okay, all right. So all right, it could be something simple, something complex. Okay, all right. Specific syntax for particular program of a particular program may be different between languages, but all end of the day maybe solving the same problem. Okay, all right. So end of the day, all languages share these features. Okay, one is input. Okay, every process of solving a problem require an input. Okay, so regardless the programming language, we need input. Okay, so that in this class more often we're going to use keyboard as input. Okay, but in the file lesson we'll learn how to use a text file and a binary file like zeros and ones file as an input. Okay, we're going to learn that. Okay, and in the industry and in our real world it could be many, right? So keyboard is a device, but it could be mouse clicks, could be a game controller, any device, a USB device, anything, right? So those are the devices that gives input. Output, well, we get something done by a computer, right? So a program, right? So display, so we display data. Okay, so that means basically we can use the display as the output. Okay, and we can use, so that means the screen. or we can save it in a file, right? So we write into a file. Okay, so read from a file is an input, write into a file is a way of output. Okay, or it could be a device, another device that we send information as well. Okay, so for example, the internet. Okay, so we run web pages. Okay, all right. So math and logic. So every computer does that. Every program can provide a way of handling this as well. Okay, doing math and logic. In fact, significant resources goes into this process in the CPU. Okay. Selection, right? Sometimes we select something over another. So that has when we make decisions. So selection is something really common between languages. Okay, like if else, right? Conditional execution. Iteration. Well, in fact, this is the most profound thing computer does to us. Okay, so computers are way faster than human, right? So we can only do things uh, between for a single task, human take at at least 0.01 second. Well, the CPU can do it in one probably millionth of a second. So that means it's really fast. We can automate things, and that's why computers is really popular. It beaten humans profoundly in repeating things, repetition. That's why it's really popular. Okay, so it's still a dumb machine. I mean, it's really dumber than human brain. We cannot make these make inferences and then decisions based on that, right? It only does what we tell it to do. So, but it can do it really fast. So iteration is the last. So that also a common operation among language. Okay. All right. The other thing is in programming is, well, we write programs. So human does it. So whenever human does thing, well, mistakes happen. Well, we call it human error, right? So we do a lot of mistakes, humans. So we call them, when it happens in the program, call them bugs. And you can click on over here. So let's click right here, and it will take us to the first bug reported uh, back in very early days of computing. Okay, so this is the bug. It's actual bug they found, because these are like this computer is like a big house size one, and they have this really big circuit board. So there was a bug, probably short circuiting a circuit, and then they found it, and then they attached the bug to the report. So um, many say the persons who are associated with this finding was Grace Hopper was in that team, and then she actually coined the term, and then a lot of credit goes to her, because she sort of made it popular uh, by making this as a concept in computer science, bugs and debugging. Okay, all right, so let's go back to our lesson. Okay, all right, so that's we call them bugs. Okay, so debugging is the process of removing those bugs. Okay, so there are three main types of bugs. Okay, we will encounter them throughout this class as well. So first one is syntax errors. So there's a specific syntax or a grammar in the programming language. So when we make mistakes, well, the the translator catch it, and before we run it, it tells that, okay, so we have an error like this and this. We call them syntax. Okay. So syntax errors, with syntax errors, you cannot run your program. Basically, you cannot completely run your program. Okay. All right. So logical or semantics errors, basically these errors, um, um, due to these errors, program still runs, but you're not getting the expected outcome. Okay, so you will not get the expected result. You'll get something wrong. Okay, so that's why we call them logical errors. So it runs, but not expected results. So we call them logic. So that means basically there's a mistake in the logic of the program. So that means we say the semantics of the program is wrong. And these are the kind of bug really hard to debug, okay, because it runs. So the compiler system or translator doesn't complain, so it runs. And when we see it's not properly giving the expected outcome, then we have to basically find out line by line where and what we are doing the mistake. Okay, so that takes time. So it's compared to syntax errors, these are hard to catch. Okay, so they don't return errors, right? And basically logic or the algorithm could be wrong. So algorithm could be wrong as well, or in the logic of the code. Okay. So runtime mirrors, basically no compiling errors, and basically all of a sudden during the run of the program, it crashes. So we call it runtime errors. Like for example, file not found exception. So basically we are using a file inside a program, but when Python goes and check for the file, it cannot find the file. So program at that point basically crashes if we are not properly handling exceptions, which by the way we're going to learn towards the very end of this class. Okay. All right. So we're going to run our first program now. Okay. So what I'm going to do is basically I'm going to copy paste this, okay, into my interpreter. Okay. All right. So today I'm going to use this Google Collaboratory platform. So this is our first program. So I'm going to copy paste this code over here. Okay. All right. So I'm going to simply run it. Okay. All right. So it seems like print hello world. So I printed hello world. Okay. So I'm going to show you over here. So in this location, I'm going to show you how we can do the same using Jupyter platform. So guys, don't get overwhelmed. Okay. So I'm showing you a few options over here. You don't need to be master of all these options. Okay. If you can do this for now using Google Collaboratory and run Python, that is perfectly fine. So I'm going to show you how to run Jupyter as well. So here's what I do. Okay. So I type Jupyter Python. So Jupyter notebook. Yeah. Okay. So hit enter. And you can do it in Windows. You can do it in Mac. You can do it in Linux as well. All right. So it's going to basically run a local web server and create a web page, and it automatically goes to your default browser. In my case, it's Chrome, and open the Jupyter notebook. So this is basically the user interface of Jupyter notebook server. So now create a notebook. I click new button, new, And I created the separate environment for Python 3.9 because if I run Python 3, it will be Python 3.7. So I created a separate environment for running Python 3.9. So I click on that. Okay. And now this is my Jupyter Notebook page. Okay, you will see that. I'll explain the interface a little bit as well. Okay. All right. So these are the code. You will notice that these two collaboratory tool and this Jupyter Python, it looks very same because Google underneath all of this runs a Jupyter Notebook. That's the reason. Okay. So underneath this whole thing is one of these. Google runs it. Okay. So this is basically much simpler than this because Google added more user experience on top of it. Okay. So we don't have that much of things here, but this is enough, right? So for example, if you don't have an internet connection, this is the way to run Python. Okay. So because it's running from your local machine. So though it goes to your browser page, it doesn't interact with the internet. Okay. All right. So you can open a file from the location we ran it. Okay. So this is what we right now have it. Okay. So you can do it, or what I'm going to do is I'm going to copy paste that code over here. Okay. And you can run your code clicking on run button. You can reload the restart the kernel, which is the server. All right. And and you can do things with these cells. Each of these is a cell. So this is a code cell. Okay. So you can add a cell, right? And you can convert a cell into Markdown. So that means this is just text. Okay. This is our first program. And I'm going to copy paste that code. Okay. Here. So this is the code box, and this is like Markdown. That means basically text, English text box. So you cannot run these. You can run these boxes, which has Python code. So let's run it. Okay. So I printed hello world and added a new box so that I can continue programming down below. Okay. There are some controls. Play with these. Okay. I'll post this file, open this file, and then try to do things like, adding things like as a calculator, you can use it, and those stuff. Okay. So you can do many things, and you can do usual copy paste things, and you can save it. Okay. So I'm going to rename this to a name. So let's say hello world, hello, and then rename. Okay. And at the end of the day, what I will be doing is basically I'm going to go over here and then download as a bunch of options Python. Okay. So that will generate the Python code. Respect to Python code. So if I open it, right, so you will see this is my that set of code. It's automatically generated, and you can run this in Python. Okay. So I'll be posting bunch of files out of just simple one program. Okay. All right. So let's go back to our presentation. Okay. So this is where we were. Okay. All right. So now I'm going to make a comparison. Okay. Python with two other popular languages. Okay. So this is Python Hello World program. Okay. This is Java Hello World program. And now you can see both programs does exact same thing. It print hello world to the command output. Okay. Now you can see the complexity in the Java program. Okay. Python is really simple, but Java, you have a lot of keywords involved. You have a lot of syntax things like curly brackets and semicolons, and then big function names, right? In Python, it's just four simple lines. Okay. In Java, we require a lot of lines, right? And in C++, the other popular language, it also the same story, similar to Java. Okay. So now you can see why Python is getting really popular. One is it's easy to read, simple, yet can like cannot get beaten by these two big guys like Java and C++ that came before Python. Okay, in fact, Python designers learned the lesson from Java and C++. By looking at Java and C++, they improve, and that's how the technology evolves, right? So Python is the youngest of both, all three. Okay, so and you can see that it's the improvement designer put the thought. Okay, all right. So next, well, this Python program perfectly fine. Okay, but you know many programmers and engineers used to Java before because Python is new, rather new, I guess, and they're used to these languages, and then this concept of that you see right the main program over here is sort of like a standard. Okay, so in order to comply with that, Python designers also provide the pathway to sort of like comply with other two these languages. So uh, this we can modify this program a little bit to add that main program as well. Okay, so sort of like now we have all three running a main program. Sometimes we call it the client or the driver program. Okay, so but nothing changed basically. Okay, all right. So let's now run that program. So I'm going to go into that, and I uh, already um, put that code over here because to save time. Okay, so basically this program, so this is sort of I am presenting right now a standard way of standard style of coding. Okay, and then some of you some of these uh, syntax, um, some of you will have a hard time understand. Totally fine, don't get afraid. We're gonna get used to this format, and then we're gonna get to know this concept pretty soon. For example, this line is basically a function definition in Python. We're gonna learn it in next week. Okay, week after next week. Okay, but this since this is a standard, and since we need something to get going, I am now sort of throwing this at you. So don't worry if you don't understand any of this for now, right? So let me explain what it does. It's still the hello world program. It prints the hello world to the output, which is the screen. All right, but it has some really nice flow designed into it. Okay, so when we get used to this design, we will be able to use our code repeatedly. So you don't. So there's a thing saying in computer science, never repeat yourself, right? So that means never write the same piece of code again and again. So what you need to do is you should be able to reuse that code that you previously wrote. So this, if you get into this habit from the get-go, that's why I'm throwing at you from on the first day, you're gonna get into this habit after a few weeks, and then it'll be like a cemented habit once you are done with with this class. Okay, and you will be basically using this way of solving problems, writing functions and then putting them in a main program and then calling that main program, and if you want, importing them again when you need it. It's a good skill to learn in software engineering. Okay, so that's what I am going to foster from today on. Okay, so that's all, but we're gonna explain this code now. Okay, but let's, for now, I'm going to run it. Okay, it printed hello world, the same thing that we did earlier in that four simple lines. Okay, so I'm going to explain this code line by line in my slides now. Okay, all right, so all right, so let's go over that. All right, it's a little bit slow, my computer, when I run Zoom. Okay, all right, so so let's analyze our program. So I copy paste, this is a screenshot of that program. Okay, all right, first one, comments start with hash mark. Okay, so this hash mark, we can use it to document what we are doing in our program. So whenever necessary, consider documenting what you are doing, because if you don't do that, then if the program is rather complex, and you will be saying to yourself, what the heck I was writing, right? So because we forget things. So and then usually in the industry, almost every industry company, software company, wants their engineers to document what they do. And then there's no other better place than the program itself to document. So you can actually say in a comment that this is what I am doing, because Python don't run code comments. Okay. All right. So these are just for you to see our descriptions. Okay. So Python ignores those lines with starting with this uh, pound symbol or the hash mark. Okay. All right. And that's comments, code comments. Function definition. So this is, we call a function definition, and as three things governed by it. So def keyword. So we call this purple things in here. This one, this, and then right here, this if. We call them reserved words. So def is the reserved word here, and then comes the function name, and we need to normal brackets, and it should end with the colon. So this whole thing is a function definition. It starts with def keyword. Okay. All right. The doc strings, the next one. This three double quotes, open and close, three double close. The thing enclosed by that is called the doc string. Okay, so this is really important. So we call this basically the docstring of the function. By the way, classes also has the same thing. Basically, this one should describe in a single line what this function does. Okay, so according to new Python style standard, this is a little bit complicated than this, but for now we're going to stick with this single line thing, and then I'll introduce the little bit more complex docstring later. But again, it's a part of the documentation. But unlike this code comments, there are Python packages and modules that can actually track this and create documentation pages. Okay, so it's really important thing. So never forget to write this one even in a simple Python function definition. Okay, so docstring enclosed by three double quotes or three triple quotes. Okay, all right. So sorry, three double quotation marks. So or three single quotation marks. Sorry about that. Okay, so we call it a docstring. It's sort of a comment used to do the documentation inside function or in a program, basically. Okay. All right. So the docstring should basically start with the verb that the function does. In this case, prints hello world to standard output. Okay. See, it's really nicely say in simple terms what it does. Okay. Prints is the verb. Okay. Hello world is the thing that it prints to standard output. So this description, once anyone read this one, they know what it does, right? All right. So that's the docstring. So it start with the verb, and then you can describe what the function does in a single line. Okay. All right. So next, print basically. So we are using we pass this whole thing, this string, we call this a string literal. So simple text phrase. Notice string literals are encloses by either uh, double quotation or single quotation. Okay, in here it's double quotation, and basically it prints things we pass to the screen. In this case, pass to should be, there's a typo here, pass to print. Okay, so this should be, let me change that to um, this should be, sorry, it's to print things we pass to it. Okay, on screen. Okay, sorry about that. So you're here, right? So we pass over here hello world, so it printed that to the screen. Okay, so print does that. So it's a built-in function in Python. Okay, print, we're going to learn more, a lot more built-in function later on. Okay, so this is a built-in function. Print is a built-in function. Okay, so it's Python provided to us. Okay, all right. So continuing with the analysis of our first program. Okay, so def main, basically the main program definition. Okay, so that's the main program. Okay, if it's another keywords used in selection, conditional selection, we're going to learn it in probably in our fourth week. Okay, about the functionality of this, okay, later. But for now, think of, okay, this is just this is checking this condition, and based on that it's running. For now, you don't need to worry about it, because you will not be tested on this. Simply the code you write inside a function, that's all will be tested. Everything else I will provide, including these definitions, this main program, and this whole thing, until I teach you those stuff. Okay, which are coming really quickly. Okay, all right. Main right here. Understand this call. This is the call to the main program. So this is only the definition. Okay, this will not get run until we call it. Okay, so eventually, until we call this will not get run. Okay, so now you can get the idea, right? So this is where I call the main. When I call the main calls this, the function I wrote, the actual solution sitting inside the function I am writing. Okay, all right. So this is a call. In here, this line is the call to print hello world. In here, this is a call to main program. Okay. All right. So let's now we're gonna switch gears into learn about values. Okay. So a value is basically entity that a program manipulates. So we already learned few values over here. Like for example, this is a string value. It's a word phrase. So we call it string literal. The type is strings. We call it a string literal, and this is a value. All right. So basically, values are the things, entities that the program manipulates. Okay, sometimes we interchangeably use the term object. Okay, all right. So, like I said earlier, we manipulated hello world as a value. Right? We took it into a function, passed it into the function, and printed it uh, to the output. Right? So we manipulated it. Okay. All right. All values are Python objects. So we call them objects. Okay. All values in Python, they are objects. Okay. So every object has these three things. Okay. It has a data type or a class. Sometimes we interchangeably use type and the class. It's same thing. Data type or a class has a value. All right. So earlier, like hello world, that phrase hello world is the value, and it has a more importantly an identity. Okay. So any object in Python has all these three things: the type, the value, the identity. Okay. All right. So to get the type, we can use type built-in function, and we pass the value that we want to get the type to figure out the type. Okay. So let's check this out. Okay. So I am going to um, create a value. So I'm going to take this one, and what I'm going to do is I'm going to add. Okay. I'm going to add code. Okay. Or maybe you can add text, and then right here I can simply say, all right, values. Okay. And then add a code. All right. And you're going to type hello world, and then you're going to print the type. Okay. Print type. Okay. And I'm going to print simply hi. Okay. So now what I'm going to do is I'm doing is basically I am trying to figure out the type of string literal. And let's see what we get. We get class string. So this str means the short term for the string class. That means string type. And this is the way Python actually prints it out. Class, and that is actually string. Okay. All right. Let's go back to, so this now you can get the idea of the way I run the lesson. Okay. I gives you the information, the theory and stuff in the PowerPoint. Then I go back to the IDE. Right now it's Google Collaboratory, and I'm going to prove it to you. Okay, so this is the proof now. I use the type function uh, to prove that. Okay, so you can use the type function to get the type or the class of any object. Okay, so we can try now a few more things, right? So print type, let's put 10. All right, so it's an it's this is an integer, so I'm expecting the type int. Okay, so let me run it again. So I get int. Okay, so that means basically, so now you get the idea, right? I give you the information in the slides, and I prove it to you in the code environment. In this case, it'll be either of it. I may be using PyCharm. I may be using the shell, the terminal itself. I may be using Jupyter, my own Jupyter. I may be using Collaboratory. Okay, depending on the thing I decided the best for you guys. Okay, but for now it's simple. You're gonna use this uh, Google Collaboratory. And by the way, I'm going to, at the end of the day, I'll be posting uh, variety of um, in variety of format so that you can pick whatever easy for you and then run it. Okay, because end of the day, you're gonna have to study it and then play with that code. So that's my expectation. Okay. All right. So let's go back to our slides. Okay. All right, so let's go. So we go over here. All right, it's it takes longer. All right, so we were here. Okay, so every data value has a type or a class in Python. Okay, so this is basically the 20 has the type int. Okay, so and hello world is string. Okay, string type. All right, so this type realize at runtime. Okay, so when Python runs the code, the type is going to get realized. Okay, so that means basically Python take the value. For example, if it is 20, Python take the 20 value and decide, oh no, that's not a word phrase, so string, it's a number. In fact, more specifically, it doesn't have decimal point, so it's an integer number. So the type is int. So uh, Python does it during the runtime. For this reason, we call Python a dynamically typed language. So that means like Java and C++, you don't need to declare a type beforehand in compile during the compile of the program. That means in the source code, you don't have to declare a type in Python. Okay, so Java and C++ both we need to declare a type before we use a value, but in Python you don't have to. So that's why you see less code in type definition in Python. In fact, nothing. Right? You just use the value. Okay, in Python. All right. All right. So if the semantics agree, we can even convert between types. For example, we can do this. So this is a string because 20 is enclosed by these two quotation marks. So this is a string type. Okay. So by the way, we'll verify. And then if we do this, we'll get the number 20. Okay. All right. So and then type intermingling is not allowed. Okay. So that means basically once you have realized your type, okay, so messing with that it's not allowed. So that means that we call that concept strongly typed. All right, so type realization happen at runtime, so it's dynamically typed, but intermingling with the type is not allowed. For example, Python doesn't allow to do this operation. For example, this is a string, right? It's enclosed by single quotation mark, so x plus 5. And if you try to do this, Python will return type error. Okay, so that means type check is built into the language. Okay, so it checks this whether it is a valid operation or not. But JavaScript, on the other hand, will return x5. Basically, it takes x, okay, it's a string. So now it's going to convert this 5 into a string and then concatenate the two string into x5. Okay, but Python doesn't do it, but JavaScript does. So that reason we call languages like JavaScript weakly typed. Okay, so basically language going to infer the type and then type convert the type into a one and then do it. Okay, so based on who comes first operation. So in this case, for JavaScript, it's the string comes first. So it's basically concatenate this into converted string converted 5 into that and then print x5. Okay, so so that reason basically we call JavaScript languages like JavaScript weakly typed, but Python is a strongly typed language. So let's test all of this now. So it's slide 16. So I'm going to put the title over here. Okay, so that you know where you were. Okay, so this should be, I'm going to change this. to slide. It was 15, right? Slide 15. Okay, and I'm going to add one more text. So that's the way it's going to be. So I'm going to put the um, title slide 16. Okay, and I will later on, before I post code, I'll put the title as well. Okay, all right. So this should be okay. Well, yeah, I'm gonna move this down. All right, slide 16, and then we're gonna add one more code, and we're gonna test out all those things that we did in there. All right, so first one we got the we got this, right? So first I'm going to show you the type of 20, right? So well, not this one right here. So I'm going to print type and 20. So this would be string. Okay, all right, it's a string now. It's not a number because it's inside. So basically string literal. So what I'm going to do is I'm going to convert this to print int. All right, this 20. Okay, all right, and I'm going to take the type of it. Okay, type. All right, so okay, so we can now run it. Okay, so in this form it's a string. Now I converted it to a integer type. So this is a number now, integer number. So notice it happens only the semantics agree. What is the semantics? This is just this to this conversion is straightforward because these are all two numbers inside, right? Right. So literally this is a string, but inside it's just nothing else, right? So we can do this conversion safely. So on the other hand, if we try to do this, and we'll get a, let's see what we'll get. Okay, so this is like, let's see, CS20, and I'm gonna run it again. Okay, so I now get a error message. See that? It's a value error. Okay, so if the semantic doesn't agree, because how can I convert this to a number? I can't, right? Yes, it has a number as a part, but whole thing is not a number, so I cannot. So basically it says value error, so invalid literal for int. Okay, so int takes base 10 value, so it is not, it's just a text, so that's why. So for now I'm going to block this. You can unblock and then run. All right, so that's my instruction. So I'll put this kind of instruction before I post code as well, but for to save time I'm going to keep going now. Okay, so the next one we did was this one. So let's try this as well. So I'm going to copy this. All right, so guys, so the other thing I want to show you, so this is the way I arrange my PowerPoint. Only single point will be visible at a time when you run the PowerPoint. Okay, so that you can focus for that one thing. Okay, and like for example, right here, like this, right? So only single point comes, then the next one comes, the previous one disappeared. Then I sometimes I highlight the thing, catchphrases that I think should be important. I highlight them so that you guys can use it, right? And very importantly, I use this symbol for the return mark. So this says, okay, int string 20 like this returns 20, integer 20. Okay, so this symbol says return. So I will use this one for return. Okay, so let's go back. So I'm gonna copy paste that code into so the same, we are in the same slide, so I'm gonna print this as well. Okay, and this will also return a type. This will return a type error. So I blocked this one now. This is a code comment, like I said earlier. I'm not going to run this now. It's gonna skip to this one. So let's run it. Okay, so now it's a type error. Okay, so that means Python is a strongly typed language. It doesn't do this operation. Okay, so it says can only concatenate string, not int. So this is an integer, right? So you cannot add this to this. That's what it means. So we're gonna block this too. Oops. Okay. All right. So for you to test, you have to unblock and run. So to unblock, so I think this should work. Yeah. So you can toggle this blocking and unblocking by simply control in Linux and Windows. It's control slash key, the division mark. In Mac, command slash key. Okay. As you can toggle easy. Otherwise, you will need to right click and then I think yeah, comment out, uncomment, yeah, add a comment, something like that, right? So you don't have to do that. You can use the shortcut. Okay. So let's go back. So you're gonna go to next slide. Okay. Go here, here, and go to next slide. All right, variables. All right. So we already encountered variables, right? In simple math, even in the middle school, maybe even in elementary school, maybe in the middle school, definitely in the middle school, in the math class, we encountered variables, right? So like x, y, coordinates, right? Those stuff. Those are the variable. C, right? So like in mathematics, variable is a name that refers to an object in Python. Okay, so in mathematics, variable holds a value, right? For example, if the coordinate pair is x equals 10 and y equals 5, so xy 10 comma 5, right? That's what we write. So x equals 10, y equals 5. So same thing here. So variable name in math, let's say if it's coordinate x, and in Python, it's a variable name, refers to an object. So it refers to this. This wording is really important, and you will understand more of it later. But this wording is really important. It refers to an object. Okay. All right. So that's where the key difference between mathematics and Python you will see. Okay. All right. So use variables for bookkeeping values. Right? So if we use a value, then when we want to use it again and again, we have to repeat that variable, right? So for example, let's say you have a value that is a paragraph of text, well, which is let's say five lines of text. So it's a string. Now let's say you have to reuse again and again in code. So you will be basically copy pasting that big paragraph again and again. Rather than doing that, you can actually use name for that, which is the variable. And you make a single assignment at the very beginning, and then you reuse that variable name, not the value. Okay. So that's that's the idea of bookkeeping. Okay. All right. So use equal basically the assignment statement, right? So the equal operator and assignment statement to create variables. So you can create variables like this. For example, this is the variable name is planet name that equals Mars. So the planet is Mars. Okay. So all right. So assignment. So this is really important. Assignment statement which is statement that we have this guy, only works left to right. This is really important that you understand. In mathematics, it works either way, right? From left to right and right to left. If it's something equal to something, then it works either way in mathematics. Usually in numbers, when we deal with numbers, but in programming, especially in Python, there are other languages that differs in here, but especially in Python, this works only from left to right. Okay, so then please do not follow math in assignment statement. Okay, that means if you try to treat it like the way you see an equation and the equal sign and the equation in mathematics, if you try to treat the same way here, you're gonna get you're gonna misled basically. Okay, all right. So don't follow algebra here. Read it like this. So we have the planet name, which is the name assigned to. So you can read it like this: name assigned to or referring to the value mass. Okay, or use the reference diagram. Okay, so this is the reference diagram. Okay, planet name referring to mass. So this is the other use of this right arrow key. Okay, in this case it's saying it's not return. Okay, say in this case saying planet name is referring to mass. So and the other important thing over here is there are two uses of to this right arrow key. One is returns, one is referring to mass. Okay, not the same thing though, sort of there's a similarity. Okay, moving on. All right, so variable name in Python, we call them identifiers commonly. Okay, so identifiers can be a function, identifier can be a class, identifier can be a module, entire module. Right, so we'll be learning modules pretty soon. Um, um, right, and then it could be simple, just value like 20. Okay, so commonly we call them identifiers, and there's a convention for naming identifiers. So let's just quickly click on that. Okay, all right, so this is the Python style guide. So I copied to the direct place where it's written. So you guys need to check this. So click the link on the slides and you will come over here and read this few paragraphs. Okay, so names to avoid. Okay, so there's some letters, there's a really like we cannot distinguish like between 1 and L sometimes, big I and L, small L, so you can avoid those. And also and then there's some criteria that we need to follow. Okay, so we're going to learn few over here, but please read these few paragraphs. Okay, so so we're going to come over here and all right, so an identifier name must begin with a letter or an underscore. Right, so use of underscore in regular names is pretty uncommon and discouraged, though it's allowed. We use the underscore in front of a name only to define variable names as internals. Uh, I will later on explain what are internals. Okay, um, so it must variable name, so identifier name must begin with the letter or underscore. Okay, those can have special characters or spaces. Okay, so it means you cannot have an exclamation mark inside to identify a name or spaces. Okay, all right, you cannot use Python keywords. Right, so that means you cannot start a variable name with you cannot use variable names as Python keywords as variable names. You can't use. Okay, right. So naming violations return syntax errors. Okay, all right. So always use expressive names. right? So that's basically you will be helping yourself, let alone your peers, like your team members or anyone who work with, right? So basically, because if you have an expressive name, it has a description built in what it is. So it's easy to read and understand. So in interviews, many interviewers basically rate interviewees based on these kind of actions. So for example, if you use really vague names in your coding interview, well, interviewer may not be liking it and then rate you poorly, right? So it's obvious, right? So and it also tells you a lot about you as a character, right? Because writing expressive names takes time, takes patience, and it tells you about this soft skill that you have. Okay, you have patience, you have, um, um, and then also you think about others who read your code, which is all you think about. You are basically now a giver here because you think about them as well. That says a lot about unselfishness, right? So these are really important soft skill in out there in the real world. So um, believe it or not, interviewers take this also into account. Sometimes your program is wrong, but you did this really nicely formatted code, and then this still ends a positive feeling to the interviewer. Okay, so be take those things into habits from this class, and you'll get into those good habits, because when you do a good thing again and again, it will become a good habit. So let's do it in from the day one. And I set the example already, right? So you saw that my hello world program, not just like it has two words, hello world, and it has, for example, right here, this function, um, it says print hello world, not just hello world, right? So it's really expressive. It says what it does. Okay, so that what I mean by being expressive. Okay, all right. So use expressive name. So we were over here. So let me um, go into, like, let's try a few things in the code. Let's see if we can. We try 16 slide. Um, there's nothing to test over here, so we're gonna go to slide 18 and test out this syntax error in name violations. We're gonna try a few things. Okay, so slide, excuse me, I'm gonna add text. So that's slide 18. Right, so we need to send this down. Okay, it should be, so I should send this, okay, right here. Okay, so send it down. All right, send it down. One more. All right, so it's not okay. Yeah, one more. And one more. Okay, and then right here, add code. All right, so let's take few variables. So I'm going to take this variable def equals 10. Okay, so I'm going to run it. Okay, well, that's a syntax error, right? So let's see, because well, I cannot use this as a um, variable name because this is a keyword in function, right? So same with, like, let's say a number. Okay, so now there's a space over here. Okay, so let me run it again, and it's also still syntax error because, well, it's supposed to be an underscore over here. Okay, And if you want to put a descriptive name, separate them using an underscore. Don't use the camel case. Okay, so that's Java and C++ probably, but in Python the standard is separate your descriptors in your variable name. That means separate the items like names or words in your variable name with the underscore. Okay. Okay. All right. So this would work. Okay. All right. So just simply just ran it. Okay. So to see, you need to print that variable. Okay. So number. So we can actually it gives you suggestions. Okay. All right. So number 10. All right. So other things you cannot use. Let's say like this number equals 20. Okay. If you run it, okay, that also syntax. It's an error basically. Okay. So let's say see it didn't run. Okay. So if you try to print it, you get the same kind of error. Okay. So okay. All right. So let's try it. Same thing. Okay. It's again syntax error. Okay. So because I have a special character in front of the name. Same with the number as well. So let me just put a number there like 2 and try to print it. Okay. So we cannot have numbers too. Okay. It's again a syntax error. Okay. All right. So let's go back to our, I think this will be our last few slides. Okay. So, okay. Yeah, this lesson a little bit longer than that I anticipated. Okay. It's because I wanted to show things to you more like more with more information, but going forward we should have like 45 to 50 to 1 hour long lessons. Okay. All right. So this is the last topic, and it's really important as well, the identity. So we talk about those two things, right? Three things: the value, the type, the identity. So this last thing. Okay. So every object has an identity in Python. Okay. So basically identity, the value, and the type, all three uniquely identify an object in Python. Okay. So how do we find the identity? We use the ID built-in function, and then we pass whatever the object we have, and it returns the identity, which is the ID of an object of this object. Okay. All right. So ID basically it's a value, it's a unique integer value, and it's related to memory location of that value, basically that object. Okay. So ID is related to the memory location, okay, of that object. So in C Python, which is basically we implement the Python that we work with in C language. Basically, Python designers use C program to write the next high level program, which is Python. Okay, so in other words, regular Python is written in C. Okay, in C Python, it's exactly the memory location of the object. Okay, so two different variables can have same ID value. Okay, if that happens, we say the two are aliased. Okay, all right. So we're going to learn more about this concept later on. Okay, so we say they are aliased. Okay, so we will learn more about ID and aliasing later in a few weeks time. Okay, so don't worry if you can't get this idea properly, don't worry about it. Okay, so we're going to learn it again. Okay, all right. Statements. Okay, so a single instruction Python can run is a statement. Sometimes, usually it's a single line of code. Okay, so more often it's a single line of code. So statement, it's a single instruction Python can run. Okay, all right. So it's really important. Single instruction Python can run. Okay, can be a single line or multi-line as well. Okay, all right. So assignment statement. So that's a type of a statement. So here's an example: course number equals 20. Assignment statement. Okay. Loops. We're going to learn about for loops, while loops, like iterations. Those statements, we call them an if else and an with statement. We're going to all learn about all of these in the future. They are called compound statement because they have, those statements are bigger, and inside we have single line statements too. Okay, so we call them compound statements. So often assignment statement, especially assignment statement, more often, many statements, they get silently executed. They don't show you a value in the screen. Okay, they often get silently executed. All right, expression, combination of values, operators, variables, function calls, they're all expressions. And it's really important to understand the difference between a statement and an expression. The key difference is basically when you run a statement, more often it doesn't give you anything, it doesn't print anything to the screen. But when you run an expression, it will print the value. Okay, so usually expression sits at the right hand side of an assignment statement. Okay, so like x equals y. So in the expression here is basically sorry, let's say x equal 10, and the 10 sitting on the right hand side is the expression. Okay, so in an assignment statement, expression usually sits on the right hand side. All right, evaluation of an expression returns a value. So that's sort of the key difference between statement and um, expressions. Okay, so value or a variable itself is an expression. Okay, and we're going to check on those. Okay, expression can be parts of a statement, and we saw that, right? So if you take assignment statement, the right hand side, which is a part of assignment statement, is an expression. Okay, all right, so that's it. Okay, so that's our last slide. So let's check the slides. I think we can test things. You can check the ID. This is slide 19, and then all the yeah. So let's check on those. Okay, so I'm going to block these. Okay. Oops. And right here also. Okay, and then I'm going to add plus text. All right, so slide 19. Okay, so so we're gonna take, I check slide 19, the ID values. So let me take a ID value of few objects. So I'm gonna take ID print ID of, oops, ID of, say, like 20. All right, so oops, this is text. Oh, this is not the one. All right, so I'm gonna pass code block. Okay, and then play it. Okay, so this is the ID value. See that it's a big integer number. It's an integer number. It's unique to this 20 value right now. Okay, so and then You can create one more variable, and then you can create several variables with that has the same value, and then an ID could be same. So for example, let me create like um, variable 1 equals 20 and variable 2 equals 20, and I'm going to check basically print ID of both. Okay, so var1 and both, so variable 2. Okay, and check. Okay, see that we got the same value. Okay, so then two different variables over here. In fact, there are three including this one, so got the same value. Okay, so let's add one more text, that is slide 20. Okay, all right, so that is about statements and expressions. Okay, so we're gonna add code. All right, so this is a statement. Okay, so if I run this, oops, I'm gonna run it over here. Okay, well, nothing happened. All right, you see that nothing happened. So that's why basically, especially the assignment statement, when you run it, you will not see anything, but behind the scene, you will see that this variable 1 gonna get assigned the value 20. So variable 1 will be referring to, right, var1 will be referring to value 20. Okay, but if you so these are the part of this is a part, this expression, this is an expression which is a part of statement. If I simply put 20 over here, right, now Python printed 20. So expression on the other hand gets evaluated and the value gonna get returned to the output. And it's the same way if I put variable itself as well name. Okay, right, so that also get printed. Okay, so that's why it said okay, so expressions, it's right here, um, right, it returns a value, and then statements on the other hand get silently executed. Okay, so that's it's really important to understand this difference, because there's everywhere in programming, especially in Python, even in advanced, you're going to get referred to these two key terms, expression and the statement. So it's really important that you identify the difference. Okay, all right, so an expression, a single statement may be made of several expressions. Okay, all right guys, so that's the end of the slides. So I'll be posting this tonight and into the module 2. I'll see you in Canvas. Bye for now.